Welcome to this new tutorial. Here we will explain these mysterious things that we see here in the database, which are the concept of indexed, unique, and foreign key. Also, we will see this advanced part that allows you to optimize the database for faster access time or handling large amount of data. What does this mean? Okay, let's get started. So when it comes to the database, there are three concepts that are important. One is integrity of the data, one is reading fast, and the other one is writing fast to the database. When it comes to integrity of the data, then is when you want to use unique, because in this case, if the ID is unique for each one of the people in the table, then that means that you can ensure that everything will be unique by using the unique feature here. This means that the database will not allow having different IDs for different people. This is related to integrity of the data. And similar to the integrity using the unique checkbox here, you can use the foreign keys. To make a foreign key available, it has to be unique. In this case, we can use the ID of the people table in the person ID of the orders database, which means that there will be a relationship between the person ID here and the people table ID. For integrity purposes, that means that you will not be able to write in the database a person ID that doesn't exist in the people table. So that's it. This also allows someone who sees this database to understand that this person ID is associated to this table. This allows people who are developing the model with you to understand what this person ID means. So we have the integrity part, and we have the understanding the model and the database part. In general, the foreign key doesn't have any other purpose. If you try to write into the database an ID for a person that doesn't exist, you will get an error. This is the integrity part. And it's important to say that when you have a foreign key here, it's automatically indexed in AnyLogic. If there's no foreign key, you have to choose if you want to index it or not. So what does it mean to index something? It means that you will add information to the database, so you're using more memory to create a dictionary that allows the database engine to find this person ID faster. But having a dictionary here, for example, for the person ID, if 95% of the person ID values is the same, and you want to filter by that value, indexing has less value. Indexing will have more value the more the values of a column are unique. It will make sense to index if you're filtering values in the database. If you're selecting all the database, then it doesn't make sense to index, and it will make it even slower. Indexing has no value when you're not filtering. So if you have something like this, where you will select everything from the orders DB, indexing any of the columns is not very relevant. But if you're using something like this, where you select from the people table, where people's age is 33, then it makes total sense to actually index the age, because it will be faster to find all the elements of this table that fulfill this condition. So what you're doing by indexing the age is that you're creating a dictionary using additional disk space in order to make it easier for the database engine to find things based on a particular filter. But okay, if your database is very small, this doesn't make much of a difference really. What matters is when your database is really big. For example, you have millions or tens of millions of data points or rows. In here, AnyLogic offers this option where it says that you should use faster access time when the table has less than 50,000 rows. But this 50,000 rows is completely arbitrary, because what counts is not only the rows, but also the number of columns. So 50,000 is a very conservative value that helps maybe beginners. Nevertheless, there's a problem. If you have more than 50,000 rows, in my case here I have 500,000, if I use handling large amount of data, which sounds reasonable since I have more than 50,000 rows, and I don't index my age and I filter by age, this will take significantly more time. Now, what is the difference between these two options? When you use faster access time, what AnyLogic does is it loads the whole table into memory and it will read the whole table. When you use handling large amount of data, it will not load the whole table into the database. It will cache part of the database, and that means that this will be slower. It will use less memory, but it will be slower. Nevertheless, when you're using filters, it will be faster if you index by the value that you're filtering, in most cases. What does this mean? That when you're filtering by age and you're using this option, it will not load the whole database into the memory. Instead, it will load only what is needed based on the dictionary that you're using for your age. So that means that only a tiny section of this table will be loaded. This is the faster option, the combination handling large amount of data with indexing by the column that you're filtering. But if you're not filtering and you're selecting the whole table to load it into AnyLogic, using faster access time, even if you have a million rows, will be faster, and the additional memory usage is not relevant enough if you don't have too many columns. So you have to a little bit play with all this depending on what table you're using. But 50,000 is a very conservative value, and you may want to consider having a million here or 500,000. I don't know the number, it depends on the number of columns. In my opinion, for most of the projects, the only reason why I wouldn't use faster access time if I'm not indexing, which means that I'm reading the whole table, is if the database or the table is so big that my memory cannot even handle it. So you're talking about maybe tens of millions of rows with a lot of columns. But if you're filtering, this is better to do it, it's better to use it even if with a low number of rows, as long as you're indexing. So in general, but there will be exceptions, the slowest way to do this is by handling large amount of data and not indexing. The fastest is by handling large amount of data and indexing. But if you're not filtering, faster access without indexing is the best you can do, with the only exception being that your memory cannot even handle loading the whole database, in which case handling large amount of data, not indexing, or indexing, it doesn't matter in that case if you're not filtering. But the most common thing you do in AnyLogic is reading the whole table without filtering, or maybe you filter it, it doesn't matter, and you save all the values in a collection using a class. So in this case, I have an order class, which has the ID, the number, and the person ID. I have a collection, which is an array list with the element class as order. So I read the whole database and I fill this collection. And when I filter using Java itself with the find all, for example, or using streams, this is so much faster to a level that is not even worth comparing to reading from the database. So in general, it's best practice to just read the database and filter using Java. Or if I want to say it better, you read the database, whatever you need, filtering or not, but during runtime, after this initialization, and you only read the database when you initialize, during runtime, you always filter using these functions without reading the database ever again. And finally, when it comes to writing into the database, you don't want to index. Indexing makes writing, updating a database slow. But in general, you also don't want to modify your database unless you're doing some sort of digital twin connecting to an external database that we're not going to touch on this tutorial. What we generally use writing into the database for is when you export data. And when you export data, indexing is not important. And also this doesn't matter because you're not reading. So I'm not going to talk a lot about writing into the database because these elements are not relevant.